Good morning students. In this video we will discuss about third normal form. In shortcut we can call it as 3NF. It was also originally developed by EF Cord in 1971. Even 2NF was designed by EF Cord only in the same year 1971. Now remember 2 points. Whenever we are discussing about 2NF, we said that the relation should be in 1NF and it should not consist of any partial dependencies. When it comes to 3NF, the relation should be in 2NF. If the relation is not in 2NF, we can directly say that it will be not in the 3NF. If the relation is in 2NF and it does not consist of any transitive dependencies, then I can say that it is there in the 3NF. Let me read it again. It must be in 2NF and should not consist of any transitive dependencies. Okay, dependency or dependencies. Okay, then I will say that the relation R is in 3NF. Now you can ask me, sir, what is the transitive dependency? We know that what is the prime attributes or non-prime attributes. If you have x determines y, where y is a non-prime attribute and x is also a non-prime attribute, then I will call it as a transitive dependency. Let me repeat again. If you have a FD, x determines y is there, where y is a non-prime attribute and x is also a non-prime attribute, then I can say that it is a transitive dependent. These kind of dependencies are not allowed in the 3NF. Okay. So for better understanding, I have taken one example and we will solve it so that you can understand the concept in a better way. They have taken a relation R consists of attributes x, y, z. And they have given the two FDs, even they have given the candidate keys also. If they have not given, you must calculate the candidate key. In the earlier videos, I have discussed how to compute the candidate key. If you don't know how to compute the candidate key, I request you to go through the previous videos, learn how to calculate the candidate key and solve this question. Okay, so as they have given the candidate key, what are the key attributes? The key attributes are prime attributes. Let me use the prime attribute only. The prime attributes are x, y, z. The non-prime attributes are empty. Okay, there are no non-prime attributes because all the attributes which are part in the candidate key will become as a prime attributes. What is a non-prime attributes? The attributes which are there in the original relation R and which is not present in prime attributes. Then if you see that all attributes are there in the prime attributes, then non-prime attributes is an empty set. So now once we got the prime attributes and non-prime attributes, we can easily check whether it is there in the partial dependency, transitive dependency, all these things. If we have any partial dependency, then we can say that it is not in 2NF. If the relation is not in 2NF, it will not be there in the 3NF. If it does not consist of any partial dependency, meaning is that it is in 2NF and does not consist of any transitive dependency, then I will say that the relation R is in 3NF. Now come to this one. XY determines Z. Okay. Now if you see that Z is not a non-prime attribute, Z is a prime attribute. So even it is not a partial dependency, transitive dependency. So I will write it as it is not a partial dependency, not a transitive dependency. Is it clear? What is the partial dependency? The left hand side should be a part of the candidate key. Here complete candidate key is there and right hand side should be a non-prime attribute. Even right hand side is a prime attribute. So I can say that it is not a partial dependency. What about the transitive dependency? Left hand side should be a non-prime attribute and right hand side should be a non-prime attribute. Then I will say that it is a transitive dependency. Even it is not a transitive dependency. Come to this one. Z is a prime attribute. Okay. Okay, we will see whether it is a partial dependency or not. Z is a prime attribute. Okay, no problem. But Z is a part of the candidate key. Then people will say that it is a partial dependency. No. Come to the right hand side. X is a prime attribute. When we can say that it is a partial dependency? X if it is a non-prime attribute. Meaning is that right hand side if you have a non-prime attribute, left hand side if you have a part of the candidate key, then it is but left hand side is satisfied. It is a part of the kinetic behavior because the kinetic is yz. But whereas right hand side is a prime attribute, so it is not a partial dependency. Even it is not a transfer dependency. Why? Both left hand side and right hand side should be non-prime attributes. Whereas if you see left hand side is a prime attribute, right hand side is also prime attribute. It does not consist of transfer dependencies and partial dependencies. As it does not consist of partial dependencies, I can say that it is in 2NF. And it does not consist of transfer dependencies. Transfer dependencies are not there, so I can say that it is in the 3NF. Okay, so I hope you have understood the introduction to the 3NF and the example how to check whether the relation is in 3NF or not. Okay, in the next video we will solve few more examples so that you will understand the concept in a better way. Thank you so much.